day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So in today's lesson, we'll be focusing on the knowledge area mechanics, which has a total of 93 marks. And the topic for today will be on Newton's second law. That is going to be a part of your paper 1, which is question 2, and it has a total of 21 marks. Okay, so just a reminder, learners, if you have any questions, we have a WhatsApp number where you can send all your questions to, and the WhatsApp number is 063 508 1301. Okay, and Newton's second law will be under paper 1, and for paper 1 this is your structure. So you have section A, which has 10 multiple choice questions and has a total of 20 marks. Then you are going to have either 8 matching items or 1 word items, which will have a total of 8 marks. Then again you are going to have your section B, which consists of structured or long questions, and it has a total of 122 marks. Then the total for paper 1 will then be 150 marks with a duration of 3 hours. Okay, so last time, remember we focused on Newton's first law. And on Newton's first law, we then covered inertia and mass. So we covered these two. We covered inertia, we covered mass. And for today's lesson, we are going to be focusing on Newton's second law, whereby we are going to use the formula F net is equals to ma. And as part of Newton's first law, we also focused on the acceleration. And for Newton's second law, we are going to be focusing on the free body and the force diagrams. Okay, so the definitions that we need for Newton's second law are the following. We will need the normal force, which is represented by the capital letter N, or it can also be represented by capital letter F and a small capital letter N. So capital letter F and small capital letter N. It says the perpendicular force exerted by a surface on an object that lies on that object. So as a representation of the normal force, let's say this was your object, and you needed to draw your normal force. This is what you are going to do. The definition says it is the perpendicular what? The perpendicular force that is exerted by a surface. So if this is your object, if this box is your object and this is your surface, then you are going to draw that force. You are going to draw that force to be perpendicular. So it will be in that way, and the force must touch the surface. Then you would then indicate your normal force with the capital letter N or with the capital letter F and capital letter N. Then we have different scenarios in terms of the normal force. Number 1, we'll have a scenario where you have the horizontal surface. Number 2, we'll have a scenario where you have a pulling force. Number 3, we'll have a scenario where you have a pushing force. So with this illustration that I did here, it is when you have the normal force on a horizontal surface. So it's a horizontal surface. Horizontal surface, remember, it lies where? It lies around the x-axis. Then the pulling force and the pushing force, I will do them later on. Next, we have the weight or W. Weight or W, it says the gravitational force that the Earth exerts on any object on or near its surface. So with this one, you are going to need to represent it again on your object. And what you need to know is that with the gravitational force, it needs to be drawn from the center of the object, and it will always be going downwards. So the weight or the gravitational force, you can represent it using the word W, or you can represent it using Fg. So going forward, I will be using the word capital letter F and small letter G. Then we have the applied force. Applied force, it's capital letter F, or you can also represent it using capital letter F and capital letter A. It says a force that is applied to an object by a person or another object. So with the applied force, again, you will need to represent it on your object. And again, for the applied force, we can have different scenarios as well. So the applied force can be applied horizontally, or you can have the applied force whereby you have the pulling force, or you can have the applied force where you have the pushing force, that is where at an angle. Then next we have the frictional force. It says the force parallel to the surface that opposes the motion of the object. So again, you will need to be able to represent the frictional force. So if this is your object, the definition says it is the force that is parallel to the surface. So remember, the x-axis represents your surface, and then this force must be parallel. So parallel to the x-axis, maybe let's say that the friction is to the left-hand side, and then it says that opposes the motion of the object. So let's say that an object is moving in which direction? If an object is moving to the right, the frictional force must oppose the motion. So if to the right hand side we have what? If to the right hand side we have the applied force, then the frictional force will be in which direction? To the left hand side. And if maybe the object is moving where? If the object is moving to the left hand side, then the frictional force will be where? It's going to be on the right hand side. Then it says here that we have two types of friction. Number one, we have your kinetic friction. It says frictional force that acts between the two surfaces when the object is what? When the object is moving. So this is the friction that we have when the object is what? Is in motion, when the object is moving. And then how do we represent this kinetic friction? We are going to represent this kinetic friction using a small letter F and a small letter K. So let's say that now you have the very same free body diagram and you have what? Your kinetic friction. Then you are just simply going to write your F and your small letter K. So that would be your kinetic friction. Then we have your static friction. It says frictional force that acts between the two surfaces when the object is what? Is stationary. So static friction when the object is stationary, and then the kinetic friction when the object is what? Is moving. So static friction, we would represent it using small letter F and small letter S. So the K on this kinetic kinetic friction, yes, it represents the kinetic friction, and then this one, it represents what? The static friction. So in terms of the formulas, we have Fk, so for kinetic friction or for friction in general, so we'll have Fk is equals to mu k multiplied by what? By the normal force. And then if you are dealing with the static friction, so it's Fs is equals to mu s multiplied by the normal force. So this Fk would represent the kinetic friction. This one, the mu k, would represent the coefficient of the kinetic friction, and then this one would represent your your normal force. Again, for the static friction, Fs represents the static friction, mu s would represent the coefficient of the static friction, and then the n would represent your normal force. So what you need to know again is that the coefficient, so whether it's the coefficient of the kinetic friction or the coefficient of the static friction, these two will have no units. They will have no units. But the unit for the forces, the kinetic friction and the normal force, will be represented using what? Using Newton. Then again, what I want you to also take note of is that the relationship between the kinetic friction and the normal force, or the static friction and the normal force. So the relationship between the two is that they are directly proportional. So Fk is directly proportional to the normal force, or Fs is directly proportional to the normal force. So what does that mean? It means that as the normal force increases, the static friction will also increase. Or it can mean that as the normal force increases, then the kinetic friction will also increase. Okay, and then we have the tension. So when we speak of tension, it says a force acting on a string or a rope. And then we can represent tension using capital letter T, or we can represent tension using capital letter F and capital letter T. So as it shows here on the diagram, we have what? We have a rope between the two people. If I was to represent it maybe using boxes, so we'd have box A, and then we'd also have what? Box B. In between the two boxes, we would then have what? We would then have your tension, which can be represented by what? By Ft, or which can be represented by capital letter T. Okay. Then moving on to the force and the free body diagram. The force diagram is the one that is indicated here on the right hand side. It says the object can be simplified using a block. So that's the first thing. When you see a force diagram, then you're going to associate it with what? With a block. Then it says it shows an object with all the forces that are acting on it. So already the block represents the what? The block represents the object, and then this object is going to show you all the forces that are acting on the block. So in this case now, we have at the top here, we have your normal force. On the right, we have the applied force. At the bottom here, we have your gravitational force, or your weight. And then on the left hand side, we have your frictional force. Then it says an arrow represents a force in magnitude and what? And direction. So we know that, so if this is your arrow, so this part would represent the magnitude, and then the arrowhead will then be the one to give you the direction. So in this case, we can see that the arrow on the normal force is facing where? Upwards. And then the arrow on the applied force is facing where? To the right. The arrow on the frictional force is facing where? To the left hand side. And the arrow on the weight, or the gravitational force, is facing where? Downwards. Then it says the arrow must touch the block. So as you can see, all the arrows are in contact with the block. Then next we have the free body diagram. So it says an object is represented by a dot. So between the force and the free body diagram, all of them are very important, but normally in the examination you will be asked to draw the free body diagram. but also you need to know and prepare yourself to also draw the force diagram. So the big difference now is that the force diagram, you are going to draw it using what? A block. But the free body diagram, you are going to represent it using what? The dot. Then bullet number 2, it says every force is represented by an arrow with magnitude and what? And direction. So it's the same as a force diagram. So as we can see, every force here is represented by an arrow and then the direction. So we know the normal force, the arrow is facing upwards. The applied force is to the right. The frictional force is to the left. Gravitational force is downwards. Then it says arrows all point away from the dot, even a push. This is very, very important. Very, very important. So you must never find yourself drawing your free body diagram. So let's say now this was your dot, and maybe let's say you wanted to draw an arrow in terms of the applied force. So you must never find yourself drawing an arrow that is pointing towards the dot, because all arrows must always point away from the dot. So it says even what? Even a push. So I'll give you an example on that one later. Then it says arrows must touch the dot. So as an example, if you want to draw your forces now, and this one represents your dot, let's say again you want to draw your applied force. You must not find yourself having a space between what? Between the dot and the arrow. All the forces or all the arrows must touch the dot. As you can see on the diagram here, all the arrows are touching the dot. Then it says a force at an angle is represented by the force itself or by the components of the force. Never use both. Okay, let me repeat. It says a force at an angle is represented by the force itself or by the components of the force. You are never going to use both. So with this one, I will explain it in detail to you later on. Then it says here force and free body diagram. So this is just an example. It says an object is pulled by a constant force on a horizontal rough surface to the right. So when you see, okay, this one is clear. We can see that we have what? We have a constant force. So this constant force will then represent your applied force. But what is maybe not clear is your horizontal rough surface. So when you see the keyword rough surface, then you must know that it is an indication of your what? It is an indication of your friction. Then it says draw a labeled force and free body diagram indicating all the forces that are going to be acting on the object. So on the left hand side we have the force diagram, and then on the right hand side we have a representation of the free body diagram. So remember we said that the force diagram is represented using what? Using a box, and then we said a free body diagram is represented using what? Using a dot. So what is the first thing that you are going to be drawing? You are going to be drawing what? The normal force, and then from there, so we said the normal force will always be drawn what? Will always be drawn perpendicular to the surface. So as you can see here, this one represents your surface, which is along the x-axis, and then the normal force is therefore drawn perpendicular to the surface. And then we said that when we draw our gravitational force, we are going to be drawing it from where? From the center of the box. And we said that the gravitational force must always be drawn going where? Going downwards. And then next we have the applied force. Applied force is drawn parallel again to the horizontal axis. And then by definition again, we said the frictional force will be drawn parallel to the axis. Then this side, when it comes to the free body diagram, remember the rules. We said that all the arrows must touch the what? All the arrows must touch the dot. And then, okay, so all the arrows must touch the dots, and then we are then able to draw the what? We are then able to draw the normal force going upwards. Okay, guys, I think we are going to take a 1 minute break from here. 1 minute break. Okay, welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. I will repeat, it's 063 508 1301. We were saying that with the free body diagram, you would need to represent the same forces, and with the normal force, we said that you are going to be drawing it what? Perpendicular to the surface. So again, this represents your surface, and then the normal force will always be drawn perpendicular to the surface, so meaning it will be drawn going where? Upwards. Then the gravitational force as well, we said, will always be drawn going where? Downwards. On the right hand side, we have the applied force. So again, with the free body diagram, we need to represent the applied force. Then on the left hand side, we have the frictional force. So again, with the free body diagram, we need to indicate the frictional force. And what did we say about the frictional force? We said that it needs to be parallel to the surface. So we have pulling and pushing forces. So with the picture here, the boy on the right hand side is applying a pulling force, and then the boy on the left hand side is applying a pushing force. So if you are to represent that on your force diagram, then you would represent it in the following way. So this box would represent your object, and then the pulling force would be represented in this way. So we'd write F and capital letter A to show that we have an applied force at whatever angle, let's say at a 30-degree angle. And then for the boy on the left, we are then going to draw it this way to show that we have an applied force at whatever angle. Let's say again it's at an angle of what? Of 30 degrees. Then as I previously said, that we have different scenarios when it comes to the normal force. So again, on the object, the same definition for the normal force. It says that it acts what? It acts perpendicular to the surface. So again, this would represent your what? Your normal force. I also had a scenario for the normal force whereby it was just acting on a horizontal surface, whereby the applied force would act on a horizontal surface without you having a pulling or a pushing force. So I said that this would represent your normal force, and then going down we would represent your what? Your gravitational force, and then on this one again, this would represent your what? Your gravitational force. So if you are to draw the following using a free body diagram, how is it going to be represented? So remember, the first thing is that you need to draw a what? You need to draw a dot instead of a box. So let me just indicate one at a time. I will start with the pulling force. So pulling force is the boy on the right hand side, or is represented by the diagram on the right hand side. Pulling force, remember, I'm going to have my what? I'm going to have my normal force, and then below I'm going to have my gravitational force, and then the arrow at an angle would represent my applied force. But with the applied force at an angle, we are going to have components. So if I was to represent the components for this one, then again I would have the dot, I would have the normal force, I would have the gravitational force, and then to the right I would have a component of my applied force, which will be represented by Fx. And then I would have a component for my applied force again, which will be represented by Fy. So with that last statement, it was actually saying that when you draw the free body diagram, you need to decide if you are going to represent your applied force using just the one arrow, or you are going to draw your applied force using the components, and of which your components are what are your Fy and your Fx. So it was saying that you can never draw or use both, because in the exam when they mark you, it's either they're going to give you a mark for this diagram only, or they're going to give you a mark for this one only. So if you draw a combination of the two, then you must know that you are then going to lose a mark. So if you are again to represent the pushing force, it's going to be a similar situation. So this is what you are going to have with the pushing force. You will have your normal force, Fn at the top. At the bottom, you will have your gravitational force. But then remember, the rule said what? The arrow must never face the dot. So it means that you will have your applied force at the bottom there. And then if you are to draw that using what? Using your components, then it means that you'll have your normal force at the top. At the bottom, you'll have your gravitational force, and then the components, you'll have your Fx, and then you'll also have your what? Your Fy. So if you are to draw the free body diagram, you need to decide again if ever you're going to draw structure number 1, this one on the left, or structure number or the free body number 2. So again, the components, you need to know that if you need to do your calculations, then you will have to draw the free body diagram in terms of the components. But if they just ask you to draw the free body diagram and there's no calculations, then you can simply use the structure on the left, or you can use the structure here for the pulling force. But if there's a calculation, then calculation involved, then you are going to need to use what? The components. Okay, and I will explain the components to you later on. So next we have the definition on Newton's second law, and it says when a net force, which is your F net, is applied to an object of mass m, this object will accelerate in the direction of the net force. So if you have an object, and on this object we have a net force that is applied on this object of what? Of mass m. So this object has a mass. It says it will accelerate, so it will move in the direction of the net force. And then it says it will move, it says the acceleration A is directly proportional to what? To the net force. So this acceleration A is directly proportional to the net force and inversely proportional to the mass. So this definition is according to your examination guidelines. So what you need to do is that when you define, you are not just going to define until the word, the direction of the net force. If you do that, you will not be getting your full marks in terms of the, according to the examination guidelines. So when you define Newton's second law, you need to define it all the way to what? To mass, so that you can get your what? Your full 2 marks. Then it says the net or the resultant force, which is F net, is equals to ma. So this formula defines Newton's what? Newton's second law. And remember, from the definition we said the acceleration is directly proportional to the net force. So meaning as the net force increases, the acceleration will also what? The acceleration will also increase. So from the formula again, we are saying acceleration is directly proportional to the net force. And then the very same acceleration is what? It's inversely proportional to the mass of the object. So it means that as the mass is increasing, the acceleration will do what? The acceleration will decrease. Okay, learners, we are going to take a 1-minute break.
Excellence. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you are gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
If you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. I will repeat it for you, 063-508-1301. Okay, so as I was saying that we are going to use the formula F net is equals to MA. So F net is equals to MA. So, and with that formula, what you need to know is that the acceleration is directly proportional to the net force. So acceleration is directly proportional to the net force. So when you apply, the more force you are going to be applying, it means that you will have an increase in terms of the acceleration. So as the F net increases, then the acceleration will also increase. And then again, according to the definition, it says that the acceleration is inversely proportional to the mass of the object. So this very same acceleration is inversely proportional to the mass of the object. So as you increase the mass of the object, as you increase, so acceleration and the mass, so as you increase the mass of the object, then the acceleration will do what? The acceleration will decrease. So in terms of the data sheet, you must just know that you are going to have the following for Newton's laws in general. So you will have you are going to use your F net is equals to MA, which is what we just discussed. And then you are going to have your static friction. You are also going to use your kinetic friction. And then this one, which is your FG, is equals to mg. And I will explain it again as we do the calculations. Then it says for calculations of Newton's second law, it says you need to use, so this is according to the examination guidelines. It says you need to use the equation F net is equals to MA to solve problems involving forces, mass, and acceleration in the content of technology. Then it says do not include pulley problems and your lift problems. So as we do our examples, I'm also not going to include the following. Then it says you need to apply Newton's laws to a variety of equilibrium and non-equilibrium problems, including a single object. And then it says moving on a horizontal plane with or without friction. So a single object, we are simply just talking about one, so that would be represented by one box. Or if it's then two objects, then we are talking about what? Two objects. Then it says moving on a horizontal plane with or without friction. So again, we can have what? A single object that is moving on a horizontal plane. So that is your x-axis. And then this object can then have friction, or it can be without what? A friction. Then we can have again a single object or two objects that are moving where? On a vertical plane, that is along your y-axis. And then we can have a two-body system which is joined by a light inextensible string. So we can have two objects which are joined by a rope. Remember, rope is represented by what? By tension. Capital letter T or capital letter F and capital letter T. And then the last one, it says both on a flat horizontal plane with or without what? Without friction. So just a similar scenario again, on a horizontal plane with or without what? Your friction. Then the next one is you need to know the graphs. So on the following, it says here the heading is Newton's second law, and then on the y-axis you are given your acceleration, and then you know that acceleration is represented by small letter a, and then on the x-axis you are given your net force, which is represented by F net. So you need to know how to use the graphs in order to calculate whatever that you are given. So in terms of Newton's second law, we know that F net is equals to what? Is equals to ma. And then as I've said, so on the y-axis we have acceleration, which is represented by a, and then on the x-axis we have your F net or your net force. So what you need to know is that if you divide the y-axis with the x-axis, you are going to get your gradient. So a division of the y-axis with your x-axis, it gives us what? M, which represents your gradient. So in this case, we need to manipulate this gradient, or we need to manipulate this formula so that we get to what? To this gradient here. So it's F net is equals to ma. And how are we going to manipulate that? We can first start by dividing both sides with the F net. So division of both sides with F net. What will happen on the left hand side? F net divided by F net will give us what? 1, which is equals to ma divided by F net. Then next, we can see that according to the gradient that we initially wrote here, that is coming from the y-axis divided by the x-axis, we can see that we only have what? We only have acceleration and what? And the F net. So, but according to the calculation that we are busy with, we don't have, we have the acceleration and the F net, but then we also have what? The M there. So we need to find a way to get rid of the M. So mathematically, we will then multiply both sides with what? With 1 over M. So when we multiply both sides, on the right hand side, the m and the m will cancel. And then on the left hand side, we are going to be left with 1 over m. And then on the right hand side, we are then left with acceleration over the F net. Okay, so this one, the acceleration divided by the F net, we said it represents the what? It represents the gradient. So maybe as an example, they can ask you to, so they can give you this graph of the acceleration versus the net force, and then they can then ask you to calculate the mass of the object. So what is it that you are going to do? The first thing is that you need to calculate the what? The gradient. How do you calculate the gradient? You know that your gradient m is what? Change in y over the change in x. Change in y is your y2 minus y1 divided by x2 minus what? Minus your x1. So from there it means that you can then choose any points on the graph. You calculate your gradient. So let's just say that we'll use the following points. Let's say that this one represents your x1 and your y1. And then this point here at the bottom also represents this one represents x1, y1, and then this one would represent your x2 and your y2. So how are you going to do it? If this point here, y2 is your what? Your y-axis, it would then be represented by what? By 8. So let me write it over here. So it's m is equals to y2 minus y1, and then x2 minus x1. So your y2 in this case would be represented by what? By 8, and then your x2, so it means you go down the graph, it would be represented by 0.8, and then your y2 minus y1. Okay, so y1 is represented by what? By a 0, sorry about that. And then your x2 is represented by 0.8 if you go down, and then your x1 is represented by what? By a 0. So let me just repeat. I said that y2 would be represented by this dot over here, and then with that you are then going to go along the y-axis, and then you can see that along the y-axis you have what? You have 8 as your y2, and then your y1, you go along the y-axis again, and then we said the y1 would be represented by this point over here, and then the x2, we said that you are going to go down from the very same point of y2, and then when you go down along the x-axis, we can see that your x2 is represented by what? By 0.8. Then the x1, you go along the very same point of y1, and then the x1 is represented by what? By 0. So from there, you can then use your calculator to calculate the 8 divided by what? By 0.8, and then we can see that it's giving us what? It's giving us a 10 as your what? As your gradient. So from there, what have you just calculated? Remember we said that if you divide the y-axis, so in this case our y-axis is what? Is acceleration. If you divide your y-axis with your x-axis, which is f net in this case, we said that it means that you are calculating the what? You are calculating the gradient. So that is why when we manipulated the formula f net is equals to ma, what did we get? We got the acceleration divided by what? By divided by the net force. So in this case, it means that the acceleration is represented by what? By your y2 minus your y1. And then it means that the f net is represented by what? By your x2 minus your x1. So that is why we then went and said 8 minus 0 and 0.8 minus the 0. Those values are coming from where? they are coming from the very same acceleration, which represents our y-axis, and they are coming from the net force, which represents the x-axis. So from there, after calculating the gradient, you are just going to substitute the answer of the gradient. So from there, we are then going to say 1 over m is equals to a over f net. Remember, we said it is the gradient, and then we said the answer of the gradient is then what? Is then a 10. So if the question said to you, calculate the mass of the object using the graph, then what are you going to do? It means that this m here would then be representing your what? Your mass. So from there, you just apply your mass, and you need to solve for the m. So what are we going to do? We can divide again on this side by what? By 1, and then from there we can do what? Cross multiply. So we'll multiply the 1 with the 1, and then we'll multiply the m with the 10. So when we multiply 1 with the 1, it will give us a 1, and then multiplication of the m with the 10 is the same as multiplication of an x with a 10. What is it going to give you? It will give you 10x. In this case, we have an m, so it's going to give you 10 what? 10m. So from there, we can see that we need to get rid of what? We need to get rid of the 10. So how do we get rid of the 10? We need to divide both sides by 10. When you divide both sides by 10, 10 and the 10 will cancel out. And then what are you left with on the right-hand side? On the right-hand side, you are left with the m. And then on the left-hand side, what are you left with? What are you left with? You are left with 1 divided by the 10, and then you can use your calculator then to calculate that. So your m, your mass in this case, would be represented by 0.1 kilograms. Why kilograms? Because remember we said that the unit for mass is what? Is kilograms. So I will just quickly explain it again. I said that if they asked you to calculate the mass of the object given the graph, what are you supposed to do? Okay, remember the first step is that I said that a division of the y-axis with the x-axis, it gives you the gradient. So that is step number 1. A division of the y-axis with the x-axis, it gives you the gradient. So what did we do? We firstly manipulated Newton's second law formula, which is F net is equals to ma. We manipulated that to get the following, which is 1 over m, and then on the right hand side we had what? We had acceleration over the F net. And then remember we said acceleration over the F net is coming from where? The acceleration is your y-axis divided by the net force, or F net, which is your x-axis. And then we said that the very same acceleration, what did I do with it? I calculated the gradient by saying y2 minus y1, and I got the values from where? From the y-axis. And then I calculated the x-axis by saying what? x2 minus your what? Minus your x1. And then we said the x in this case is represented by what? Is represented by the F net. So we calculated the gradient using the coordinates, and the gradient gave us what? It gave us a 10. So from the 10 we said, okay, if we go back to this 1 over m is equals to the gradient to calculate the mass, how can we do that? And then that is where I then said 1 over the m is equals to what? 10, which is the very same gradient that I calculated. So from there, mathematically, what did I do? I just calculated the mass of the object and for that mass of the object, it then gave us a 0.1 kilograms. Again, learners, if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. I will repeat the numbers for you 063 508 1301. So next we have the components. Okay, so in terms of the components, then you will need to apply that knowledge of your maths. So in terms of the components, we have here our fx, and then we have here our fy, and then this line here would represent your applied force. Okay, so we are going to be using okay, let's say this angle is given as what, as 30 degrees, and then maybe you need to calculate your x components, your fx, or you need to calculate your fy. How are you going to do that? Maybe let's say you are given the applied force as an example. Let's say you are given the applied force as 3 Newton. So we can start here and say, okay, the side opposite to the angle is called your what? The side opposite to the angle is called your opposite angle, and then the other side will therefore be called your adjacent. And then if this is your opposite side, this is your adjacent, this would then represent your hypotenuse. So what are you going to do from here? We can use SOHCAHTOA. So what does that mean? This one here represents your sine theta, and then we are saying that sine theta is equals to what? Opposite over the hypotenuse. And then this one, the C, represents your cos theta, and we are saying cos theta is adjacent over the hypotenuse. And then we have tan theta, which is represented by what? By the opposite over the adjacent. Okay, so in this case, if we are to maybe calculate h, then what are we going to do? Or calculate the opposite side, then what are we going to do? So we are given what? 30 degrees. So we would then say sine 30 degrees is equals to what? The opposite is represented by fy, and then the hypotenuse is represented by what? By fa. So from here, what are you going to do? You will then say sine 30 degrees is equals to, let's say you are told to, or you are asked to calculate the vertical component. Fy represents your vertical component, which is along the what? It is along the y-axis, and then fx represents your horizontal component, which is along your what? Which is along your x-axis. So as I was saying here, that you are given what? You are given 30 degrees, and then you are maybe asked to calculate your fy. So we said sine theta, we substituted with the 30 degrees, and then we said the side opposite the angle is called your opposite side, and then the other side will then be called your adjacent, and then this one will be called your what? Your hypotenuse. So we have sine 30 degrees is equals to fy. Fy is coming from where? From the opposite side, and then divided by what? By FA, and then we said FA is given as what? As 3 Newton. So we can then be able to substitute the 3 Newton there. So from there you need to calculate your what? Your vertical component. So your vertical component is given by Fy is equals to what? It's going to be 3 sine 30 degrees. So from there you then use your calculator to calculate the vertical component, and it's giving me 1,5 Newton. So they can also ask you to calculate the horizontal component. So with the horizontal component, we said that for the cos it's going to be the adjacent divided by what? By the hypotenuse. So with the adjacent, it is then going to be cos theta is equals to, what is the adjacent? Adjacent is represented by what? By Fx, and then the hypotenuse is represented by what? By Fa. Okay, so from there our so we have cos what? We have cos 30 degrees is equals to Fx, because it's the unknown, divided by what? By Fa, which is represented by what? By the 3 Newton. So from there we are able to calculate the Fx, and it will be equal to 3 cos of what? Of 30 degrees. So 3 cos of 30 degrees, and this one gives me what? 2,60 what? Newton. So for this one, 10, what do we have? So we have 10 theta. So the theta in this case would be represented by what? By the 30 degrees. And then let's say maybe you don't have the, maybe let's say you are given the what? Let's say you are given the opposite, and the opposite we just calculated, we said it's 1,5, and you are looking for the Fx. Then you would use it in this way. Tan theta is equals to opposite, which is represented by Fy divided by what? By Fx. So already you have the 30 degrees, so we continue with it. Tan 30 degrees is equals to, our Fy is represented by what? Is represented by the 1,5, and then we said that our Fx will be the unknown. So from there, what is it that you are going to do? You just need to apply your what? You just need to apply your maths and calculate what? And calculate your Fx. So what is it that we can do to get rid of this Fx here? We can multiply both sides by what? By Fx over 1. So it's going to be Fx over 1 on the right hand side, and then Fx over 1 on the left hand side. So on the right hand side, what is going to happen? The Fx and the Fx are going to cancel, and then you're only going to be left with 1,5, and then on the right hand side, on the left hand side, you are going to be left with Fx 10 what? 10 theta. So I will just write it up here. Fx 10 theta is equals to 1,5. So again, you want to make Fx the subject of the formula. So what are you going to do? You can then divide both sides by 1030 degrees. So you will be left with Fx is equals to, let me quickly calculate, 1,5 1030. So you have about 4,3 Newton. So I just wanted to just emphasize on the horizontal component, and also emphasize on the vertical component. Okay, so moving on, it says a 6 kilogram object is pulled with a force of 60 Newton at an angle of 30 degrees across a rough surface. So remember, when we speak of what? When we speak of the rough surface, then we are speaking about what? We are speaking about the friction. So it says as shown in the diagram below. So 2.1 says here, state Newton's first law of motion in what? In words. Okay, let me just move on to the other slide. So we are given what? We are given a 6 kilogram object. So 6 kilogram object, and then it says it is pulled with a force of what? It is pulled with a force of 60 Newton. So remember, we said that we can either have a pushing force, or we can have what? A pulling force. So again, it says at an angle of what? Of 30 degrees across a rough surface, as shown in the diagram below. So we said when we see the word a rough surface, then we must know that we are dealing with what? Then we must know that we have friction. Okay, so just to go back to 2.1, it says that we need to state Newton's first law of motion in words. So remember, again, you need to define it according to the examination guidelines. So it says Newton's first law states that an object continues in a state of rest or uniform velocity unless it is acted upon by a net or a resultant force. So we already did this one, so I'm just going to move along. Then 2.2 says you must calculate the magnitude of the vertical component of the 60 Newton force. So remember, when we speak of the word what? Magnitude, then we are speaking about what? The size of that particular vector, or of that particular object that, or force that you are calculating. So it says calculate the magnitude of the vertical component of the 60 Newton force. So vertical component means that we are dealing with the what? With the y-axis. And then if we speak of the horizontal component, it means that our interest is on what? Our interest is on the x-axis. Okay, learners, we are going to be taking a 1-minute break. Okay, learners, welcome back. So if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301. Again, if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301. So we were busy with 2.2, and it says you need to calculate the magnitude of the vertical component of the 60 Newton force. So what is it that you are going to do? The vertical component is your y-axis. Okay, so it means that you can use what? Your soccer tool, vertical component. So if we are focusing on the vertical component, the side opposite to the angle is our opposite, and then this one represents the adjacent, this one will represent your hypotenuse. Okay, so what is it that you can use? We have the hypotenuse, it's given as what? As 60 Newton, and then we are looking for the opposite side. So which one would be best to use? Having the hypotenuse and looking for the opposite, so it means that we can use what? We can use sine theta. So for 2.2.1, we would then say sine theta is equals to opposite over the hypotenuse. So for the opposite, what is it that we have? It's sine theta is equals to, the opposite is represented by Fy, and then we can say that the hypotenuse is represented by the applied force. So sine what? Sine 30 degrees is equals to Fy, which is the hypotenuse, divided by what? By the 60 there. So from there we will then say Fy is equals to 60 sine 30 degrees, so that you are able to calculate your what? Your vertical component. So it's 60 sine 30 degrees, which then gives us what? 30 Newton. Now 2.2.2 says you need to calculate the frictional force experienced by the object if the coefficient of the kinetic friction between the surface and the object is what? Is 0.13. So we already know that the friction is what? It's kinetic friction, because they gave us the coefficient of the kinetic friction. So what is the formula again for the frictional force? So it will be Fk is equals to mu k multiplied by what? Multiplied by the normal force. So from there, what are you going to do? It's Fk is equals to mu k multiplied by the, so because this one is a pulling force, so remember we have a pulling force, and then we also have a pushing force. So because this one is a pulling force, then we need to represent the normal force in this way. It's going to be Fg minus what? Minus your Fy. And then if the arrow was facing the block, it means that it was going to be what? A pushing force. So if it's a pushing force, then how are you going to represent it? It's going to be Fn is equals to Fg plus by Fy. So what do we have in terms of the normal force? I will substitute. It is a F what? Fg minus what? Fy. Okay. And then we said we have the coefficient. When you break down the Fg, it becomes what? It becomes m multiplied by g, and of which g is your gravitational acceleration constant, of which you will be given on your data sheet. The m in this case represents the what? Represents the mass of the object. And then when you break down the Fy into your components, then what are you going to have? You'll have F sine what? F sine theta. So from there, you have broken down your formula, so it means that you can now be able to what? To substitute into the formula. So we were given the coefficient as what? As 0.13. The coefficient was given as 0.13, and then the mass of the object on the box there was given as what? As a 6. And then the gravitational acceleration constant, it's a constant, so that means that it is never going to change. So you will then write it, copy and paste from your data sheet as what? As 9,8. And then you have your force from the components, which is what? Which is given as 60 sine 30 degrees. The 30 degrees is the very same angle that you were given there. So from there, you can then use your calculator. 60 sine 30 degrees multiplied by, okay. So for the kinetic friction, I am getting 3,74 Newton. Let me just quickly calculate again, just to verify. 9,8 minus 60 sine 30 degrees multiplied by 0,13. Yeah, 3,74 Newton. I'm getting that as my friction. So just to remind you here on this one, so it was saying that the object is being pulled. So we can see that in terms of the arrow, the object is being pulled in which direction? The object is being pulled to the what? Is being pulled to the left hand side. So it means that where is this friction? This friction will then be on the right hand side. Why is that? Because we said that according to definition, the friction will be in the opposite direction of what? Of motion. So if the object is being pulled to the left, it means the friction will be in which direction? To the right. And then if the object is being pulled to the right, it means that the friction will be in which direction? It's going to be to the left. So again, we can check what the mark allocation on this one. So this one was 2 marks. That is why we know that we didn't need to do a lot of things on this question. So it means that we can then allocate 1 mark for the formula, or in this case, we'll allocate 1 mark for the substitution and then 1 mark for the final answer. And then this one is a total of 4 marks, so it means that we can apply 1 mark for the formula and then 1 mark for the substitution of the coefficient, 1 mark for the substitution of the normal force, and then 1 mark for the final answer. Okay, and then the next one says that we 2.2.3, it says that we need to calculate the horizontal component of the 60 Newton force. So according to the diagram, we had what? A triangle. Let me just verify. So we had a triangle. So we had a triangle, and we had what? We had the 30 degrees here, and then we were given the 60 Newton, so it was being pulled. So we had the 60 Newton, and then the first question was saying that we need to calculate the vertical component. So this one now is asking us to calculate the what? The horizontal component. So we know that if we are asked to calculate the horizontal component, then it means that we need to calculate the x-axis. So how are we going to do that? Again, we can use what? SOHCAHTOA. So for the horizontal component, it is represented by what? By fx. And then remember we said that the side opposite to the angle is called your opposite side, and then from there it means that this one would represent your hypotenuse, and then this one would represent your adjacent. Okay, so we are looking for what? We are looking for the adjacent. We have the hypotenuse, and then we also have the angle. So it means that we can then use what? Cos theta. So we'll have a cos theta is equals to the adjacent over the hypotenuse. And then from there, what are we going to do? We already know the angle, which is what? Which is 30 degrees. And then the adjacent is unknown. And it's what? It's our fx, which also represents the horizontal component. And then the hypotenuse is represented by what? By the 60 Newton. So from there, we can then be able to calculate the fx. So what are we going to do? This will then be fx is equals to 60 cos what? 30 degrees. So you can then punch that into your calculator, and I am getting 51.96 Newton for my horizontal component. So again, we can give 1 mark for the substitution and then 1 mark for the final answer, because this one has a total of what? Has a total of 2 marks. Then 2.3, it says you need to calculate the acceleration of the object. So when we are dealing with this question, we need to take into consideration in which direction the object is moving. So in this case, we said that the object is moving where? To the left-hand side. And then, so according to your free body diagram, if this is your object, according to the free body diagram, so it means that you are going to have your what? Your normal force, and then downwards you are going to have your gravitational force, and then to the right we have the what? We have the applied force. To the left, to the left we have the applied force, and then to the right we have the kinetic friction. So remember, I said that if you are just asked to draw the free body diagram, then it's either you are going to represent it this way, or you are going to represent it using what? Using the components. And I said that in terms of the calculations, you will need to represent your free body diagram using the components. So I'm going to represent it using the components. Using the components, we still have the normal force, we have the gravitational force. On the right hand side we have the kinetic friction, and then on the left hand side we are going to have 2 components, which is your fx and also your what? Your fy. So again, I'm repeating, when you represent your free body diagram, it's either you're going to go with option A or you go with what? With option B. You must not draw the 2 options, but in terms of the calculations, you are going to need the option that has what? That has the components, which is what? Which is your fx and your fy. So the question was saying by 2.3 that you need to calculate what? The acceleration of the object. So what is very important here is that you cannot do your calculations without you having to draw your free body diagram. The first step of you doing this calculation is that you need to draw your free body diagram. So we have our free body diagram, and in this case I'm going to be using the one that has what? The one that has the components. Okay, and then which forces are we going to be focusing on when we calculate the acceleration? We are going to be focusing on the horizontal forces. So for horizontal forces, we only have what? We only have fx and we only have what? Fk. That is what we are going to be focusing on. We are not going to be focusing on the vertical forces. So normally, in terms of the direction, and when I write my forces, I like to start in the direction where the object is going. In this case, the object is being pulled where? Is being pulled to the left-hand side. So what are we going to do? We firstly start by saying F net is equals to MA. And then from there, what do we have? In terms of the horizontal components, we have the Fx on the left-hand side. And then on the right-hand side, what do we have? We have the Fk. Okay, so we are then going to say Fx, so the Fk is on the other side, so what are we going to do? We are going to subtract. But let's say that you now had two forces which are on the same side. What do you do with those forces? You add those two forces. But in this case, we have one force on the left and one force on the right. What are we going to do? We need to subtract the two forces. So we have Fx minus Fk, which is equals to what? MA. And then you need to break down this one into its components. And then we had already calculated the Fx. So if we did not calculate, we would then say F cos what? Theta minus Fk is equals to MA. So in this case, remember, by 2.2.3, we have just calculated, so it means that I can just substitute the answer. So it's 51,96. And then we also had the friction. The answer for the friction was what? Was 3,74. So 3,74 is equals to, we had the mass was given, it was what? It was 6 kilograms multiplied by what? Multiplied by the acceleration. So the question said we need to calculate what? The acceleration of the object. So from there, you can just use your calculator. You subtract with the what? With the friction, and then you divide both sides with the 6. So firstly, you will subtract what you have on the left-hand side. After subtracting, then you will divide both sides with what? With the 6. And then when you divide both sides with the 6, what are you going to get? So on the right-hand side, the 6 and the 6 are going to cancel each other out. And then the answer on the left-hand side will therefore be what? 8,04 meters per second squared. That would then represent your acceleration. Okay, so in this case, the object was moving in which direction? The object was moving to the left. So if with this answer, so remember that acceleration is what? Acceleration is a vector. So it means that we need to give what? We need to give the magnitude and what? And direction. So in this case, the 8,04, it just represents the magnitude, and then the magnitude is what? Is the size. The size is 8,04. So we now need to write the what? The direction. The direction will be what? It was moving in which direction? It was moving, it's either to the left or it's going to be what? It's going to be west. So maybe we can just stick with 8,04 meters per second squared to the what? To the left. So this question has a total of how many marks? Has a total of 4 marks. So just to go through it again, you first start by writing what? F net is equals to MA. But remember, before all of that, you need to start with your what? With your free body diagram. If you don't have the free body diagram, then you will not be able to represent your forces, or you will not be able to see the forces that you have clearly. So after you have drawn your free body diagram, then you write your Newton's second law formula, which is F net is equals to MA. And then from there, on the next step, what did we consider? We considered in which direction is this object moving. So in this case, we said that the object is moving in which direction? To the left-hand side. And we said that we are going to focus on the on the horizontal forces. So in terms of the horizontal forces, what do we have? We have Fx and we also have what? Fk. And then we said if we have forces that are on opposite sides, then we are going to subtract them. But if we have forces that are on the same side, then we are going to do what? We are going to add them. So let's say that now if on the left hand side you had two forces and on the right you had one force, then what are you going to do? It means that you will first need to add the two forces which are on the left hand side, and then you subtract them with the forces which are on the right hand side. So for now we only have two. We only have Fx and what? And Fk. So you will then write your Fx, which is your horizontal component, and then you also write your what? Your Fk, which is your kinetic friction. So from there, from your horizontal component, you would substitute. So for this one, we had previously calculated the horizontal component, and then we had also previously calculated the what? The friction. And then for the mass was given, and then all we had to do was then calculate the acceleration. So lastly, we are then saying that acceleration is a vector quantity. That means that acceleration has what? It has magnitude and what? And direction. So the magnitude in this case is 8,04, and then the direction is what? Is to the left or is to west, depending on what you were given according to the statement. So it's a total of 4 marks. So we'll give a mark for what? We'll give a mark for F net is equals to MA. Then we'll give a mark for what you have on the left hand side, the substitution, and then we'll give a mark for the substitution of the mass, which is 6, and then we'll also give a mark for the final answer, but that final answer must have the correct units. And then that final answer must also have the correct what? The correct direction. Then you will get your full marks. But if you write your answer with a wrong unit, or you write your answer with a wrong direction, then it means that you will only get 3 marks for the formula, substitution on the left and the substitution on the right, but you will not get the 4th mark. Then it says 2.4, how will an increase in the angle between the applied force and the horizontal influence the friction? Write only increase, decrease, or stays the same, and then motivate your what? Motivate your answer. That is for 3 marks. So it means that for this one, you need to go back to the formula of friction, which is Fk is equals to mu k multiplied by the normal force. So remember the normal force, I said you can also represent it using capital letter F and small capital letter N. So then if we break it down, it becomes mu k, and for the normal force, because it is what? It is a pulling force, the normal force is then Fg minus what? Fy. Okay, so from there, if you break it down again, it becomes Fg, which is then mg minus F sine theta. Okay, so let me read the question again. It says, how will an increase in the angle between the applied force? So going back to the very same scenario that we have, so if you are going to increase this angle here, which was given as what? As 30 degrees. Okay, how will an increase in the angle between the applied force and the horizontal? So basically you had 30 degrees and then you now increase this angle. So an increase can be an increase to anything. let's say maybe you increase it to about 40 degrees. It says, how will this increase influence the what? Influence the friction. Right? Only increase, decrease, or stay the same, and then you need to motivate your answer. So remember, we had previously calculated the friction. We substituted what here? We substituted 0.13, and then we substituted the mass of 6, the gravitational acceleration of 9.8. We substituted all the components there to calculate the friction, and then remember, for the friction we had what? We had 3.74 Newton. So now the question is saying, if you now increase this angle of what? Of 30 degrees. So this angle here, this angle theta, how will it influence the kinetic friction there? So what are you going to do? You can then punch into your calculator, and instead of having the 30 degrees there, you then substitute this with what? With the 40 degrees. So let us quickly calculate that to say, if you now have 40 degrees instead of 30 degrees, what is going to happen to your friction? So if I now have a 40 instead of a 30, what is going to happen to the friction? So if when I had 30 degrees, my answer was what? Was 3.74. So I'm now saying, if you use the very same coefficient of friction, you use the very same mass, gravitational acceleration, the very same force, but you just change this, you just increase the angle, then what are you getting? You are getting 2.63 Newton. So I'm saying, if I now have an angle of 40 degrees, for my friction, I'm going to get 2.63 Newton. So this 2.63 Newton, now what does it mean? It means that the kinetic friction will do what? Will decrease, because that's the first thing that they're asking you. They are saying you need to write only increase, decrease, or stays the same, and then you motivate your answer. So step number 1, what is going to happen? When we had 30 degrees, it was 3.74. Now that we have 40 degrees, what is the friction now? It's 2.63. So what happened to the friction? It means that the friction did what? It decreased. Okay, so how are you going to then explain that? Remember, we said that the normal force is directly proportional. So we said that the normal force is directly proportional to the frictional force. So it means that as the normal force increases, the frictional force will also increase, or as the normal force decreases, the frictional force will also do what? Decrease. So how are we going to explain it? We can firstly start by saying that the normal force is directly proportional to the frictional force. So what happened when we decreased the angle? When we decrease the angle, it means that the normal force also decreased, and then as the normal force decreased, it also decreased the what? It also decreased the kinetic friction. So to answer that, we are saying that the first thing is that what will happen if you increase the angle? I'm repeating, if you increase the angle from 30 to 40 degrees, the kinetic friction is going to do what? The kinetic friction is going to decrease. And then you go back to this formula and say, okay, the kinetic friction is going to decrease, then what do we know about the relationship between the kinetic friction and the normal force? We know that the normal force is directly proportional to the kinetic friction. So if you increase the angle, the normal force will do what? The normal force will decrease, and therefore the kinetic friction will also decrease. Okay, so what I'm going to do is that I'm going to give you this question to try out, so you can quickly take a screenshot, and then also give you this one to try out. You can also take a screenshot on this one. And okay, so that is the end of our lesson. And with that, I'm going to leave you with this quote of Nelson Mandela. And it says, "It is in your hands to create a better world for all who live in it." Thank you so much, learners. I will see you on the next lesson, which will be next week, same time. Thank you very much.